what we're going to be doing here today is we're going to be talking about equations of best fit, okay, for data that you have. Okay, so to get into that a little bit, and for this, I'm just continuing on the slides here. So this is going to be slide 16 for this. But the first thing that you're going to be asked to do is just create a scatter plot of the data. Okay? So when you do that on your homework, it should be pretty self-explanatory. I'm not going to spend a lot of time talking about it. But the idea is that here it says plot the points. They don't have to be perfect. Okay? There's a little bit of leniency in, or that's tolerance is what it's called, in where you plot these points, but it should be pretty close. Okay, so if I'm looking to plot the point 10, 8, so here's 10 and 8 approximately. Okay, that could be 7, right? 7.5 or whatever you want to say. It's somewhere around 8. Okay, it's exactly 10, but somewhere around 8. I just plot that point and go to the next one. 13, 9 is going to be, again, just an approximation. I'm using that the point tool to plot all of these. 25, 25. Again, you can be a little more precise when it falls right on the grids. Okay, 32, 27. Again, you're just roughly estimating these. 37, 29. 38, 33, 7. Approximately here. So these are my dots, my points that I'm plotting. Now it also says then sketch a line. Okay, so then what I'm going to do is I'm going to sketch the line of best fit, which is this straight line. And what a line of best fit does is it is just an approximation of a line that passes through where it is basically the average line of these points. So if you draw a line in, and it kind of goes where there's about as many points above it as there are below, that gives you like a general sense. Now, actually, that one looked like it went through the first and the last point. That's not always going to be the case, but like this right here would be an instance where I have about 3 points below the line. I have approximately 3 points above the line. Okay, so that's a relatively good just hand-sketched line of best fit. Okay. All right, so that's all you have to do for a problem like this. And again, there is a tolerance level that allows you to be off by a little bit. Okay, when you are finding the equations of best fit, what that winds up being used for or allows you to do is allows you to make approximations of different values. Okay, so it allows you to make an estimation of what would the value be if it was a point that's not specifically given in the data set. Okay, and there's two different ways that you're going to see this used. And you do need to know the difference between these two terms. Okay, so one is interpolation versus extrapolation. Okay, so interpolation, so both of these are predictions that are made. Okay, the difference is the prefix. Inter means within. Okay, so if you're interpolating the data, that means that you're going to use that data to create an equation of best fit or a line of best fit, and then you're going to make a prediction on data that falls within the range of values given in the data set. So here in this data set here, I see it goes from 1997 to 2015. So if I find what the line of best fit is for that data, any estimation or prediction I make between 1997 and 2015 is called an interpolation. You interpolated the data. Okay, because the dates that you choose between those are going to be within the range of the inputs. Okay, now, compared to that, extra means outside of. And that means that you're making a prediction of anything that falls before 1997 or after 2015. Okay, so this is going to be still making predictions that fall outside the range of inputs. Okay, so that's the difference, and it's embedded within the word. Okay, so in this problem right here, you're being asked, estimating the value of an investment in 2003 is going to be an instance of what? Interpolating the data or extrapolating? 2003 falls within here, right? So this is interpolation. Okay, and then what if you were looking for 2018? 2018 falls outside. So this is, you extrapolate the data. Okay, or extrapolation. Okay, so that's all that question is asking, and again, it's a good question that covers the material, the terminology that's going to be used. Okay. So these are sort of the basics of it. These are the first couple questions from the homework. Okay, and then from here, the actual regression equations that we're finding, we're using our Excel or TID9 to find. We're just going to go 4 different types of equations based on what the data looks like. We first have linear regression. That is regression in the form y equals ax plus b, okay, a straight line. Right, and once again, I'm going to show you using Excel for this. Okay, and then when I get to quadratic regression, I will show you one example of the TID9, but you can also use the TID9 for this. But I do recommend using Excel. Right. So step 1, if you're trying to identify how do you use Excel to find the line of best fit. And so the first thing is this question also does have you plot points. There's the tolerance level for that too. So go ahead and just plot these 6 points really quick, or these 5 points here really quickly. All right. So this, obviously, there's not a ton of points here, and this really doesn't form a good straight line. So like linear regression is probably not what you would use for this unless you added more points, but it did specifically tell you here that you're going to use linear regression for this data. Even though, again, when you view it from the scatter plot, the linear regression, not the most suitable. It's not going to be a very accurate model. Okay, but the idea is you plot your points if that's part of the question. And then if you're using Excel, you're going to enter that data. Notice the data is two cells worth, right? It's an input and an output. So here I'm just going to type 18, 30, 33, 36, and 40. And I'm going to go over and I'm going to type my corresponding outputs, 33, 33, 32, 26, and 11. Okay, so I enter my data on my in the cells of my Excel spreadsheet. All right, next what you're going to do is you're going to highlight that data. And then you're going to choose the command that says insert. And you're going to insert a scatter plot on your spreadsheet. Now notice I don't really see it from this, I mean it's right here, but I don't see it without expanding this. So I'm going to go ahead and open Excel a little bit more. I'm going to highlight my data. Okay. Yes?
Oh, and V3 says 332.
Oh, thank you. Thank you. All right, so I'm going to highlight my data, and then I'm going to go up to where it says insert. I'm going to choose insert. And then notice under these charts, it has this point that has the scatter plot picture. Click on that, and it gives you a choice to select different variations of it. Just choose the one that's just the scatter plot. Click that, and it will put that graph of your data in your spreadsheet for you. Okay, so again, that's located right here in my spreadsheet. Once you do that, okay, you're then going to right-click on one of those points. And then you're going to choose Add Trend Line. And when you do that, you're going to select what kind of trend line you want. You want a linear equation. And you're going to go ahead and check the box that says Display Equation. Okay, so that's your next step. So if I go to any of these points right here, and I'm going to right-click on it, notice it gives me the option to add the trend line. When I select that, it gives me some choices. I'm going to go ahead and go full screen here. It gives me a choice of what type of equation I want to select. Again, normally this model right here does not fit that description. It fits more like an exponential form. Okay, but since we're being asked to choose linear, select the linear one. And then notice when you scroll down here a little bit, there's this checkbox that says Display Equation on Chart. The second you do that, it puts that equation into your graph, the plot of this for you. Right now, that is your equation for the line of best fit. Okay, so you have that. Now, in these, they will specifically tell you how they want that information provided. Okay, so when we look at the question here, okay, it says round to 2 decimal places when you enter your equation. So here, if you want to find the decimal places, to make it easiest is you could round it yourself. Okay, but if you click and select this equation box right here, so notice here, I select the equation box until I get these options, and if I choose this this format option right here, this labeling option, after that's selected, I can choose number, and I can tell it specifically how many decimal points I want it to round to. So it's at 2, it right there changed to include that, and so I get my answer to be negative 0.80 x plus 52.08. So this is my line of best fit for that data. Okay. Now, if they wanted you to evaluate this data for a specific input, what you can do on Excel is you can highlight the equation part of this, hit Control-C to copy it. You can go into any empty cell, and you can enter that. If you move in front, if you recall, an equal sign, we did this with the stats, the equal sign pulls up a formula. So if I put an equals in front of this, and then let's say I wanted to find when the time was 10. So what I would do is I would hit times, I'd replace that x with a 10, and then enter, and that would show me that my solution would be 44.08 if that was what I was trying to find. So you can go in and evaluate your data directly in Excel. And so you don't need to use a calculator separate from what you're doing here. Just enter everything in Excel, and that's, again, the easiest way to approach this. Okay. All right, so I want you to try that with the second problem. All right, so let me show you why I recommend Excel for these. If you have, like you will on your homework, you're going to have these multiple problems here. If you are using the same Excel spreadsheet for each of your questions, so here I'm just going to move this over. And let's say I want to enter this data. I don't have to delete the previous data. I'm just going to write over the top of it, and as I do, the graph will update in real time. So as I start changing the inputs, 1, 2, 3, 4, 5, and 6, notice the graph is changing. So if I go over to the other side and plot the corresponding y's, so 552, 582, 565, 560, 539, and 562. So once I hit those, as that's happening, this whole graph changed, like each time I made those. Now, my graphs originally only had 5 inputs. This one, when I click on it, so if I just click on the graph here, I see that it only highlights 4 or 5 of those. So if I go to the field, edge of the field here, and drag it down, it now includes all of that data. So I don't have to go through and do that step of inserting scatter plot, finding the trend line, displaying the equation. I don't have to do that each time. I do it one time, and then I just write my equations, and what I see is right here is the equation for the line of best fit. I've already formatted it to 2 decimal places. Again, if you want to change the decimal, highlight this box here. And if you double click on that, right where the sort of that crosshairs show up, you can choose the labeling tool here, the format tool, and that's where you can change what the decimal places are. Okay, so again, if you highlight the box, double click it, you can choose from these labeling options here. Okay, so that is the equation for the line of best fit on that second problem. So it would be y is equal to 2.40 x plus 551.60, and that is your answer. All right, questions on that? All right, I'm going to go ahead and I'm going to show with that data set here as well how to use the TID9 really quickly too. So I'll use it for the linear. Okay, so if you are going to use your TID9 to do this, right, the advantage, if there is one, to the TID9 would be not entering the data and not writing your equation. But if you have to evaluate your equation, then using the TID9 probably not that bad of an idea. I mean, like that's where it would save you the time a little bit. Okay, so if you were using a TID9 to find the line of best fit, what you will do is go to your data matrix editor, just like we did for the stat stuff. So apps, I can scroll down to the data matrix editor and select it, open the current one, and I'm going to go ahead and clear the information that's in there, although again you can just write over the top if you want. And then you enter your data. So if I enter my my inputs, and then I'm going to enter my corresponding outputs again. All right, so I have all my data entered in my Excel or in my TID9. Okay, so if you're using the TID9 for this, step 1, same thing, enter your data. Step 2, it's again the same process that you use for the stats. You're going to go to this F5 Calculate tab. And you're going to choose the same thing. You're going to choose a calculation type, but this time you have 2 variables. Okay, so you want to, or I'm sorry, let me go back to that. This time you're going to select based on what type of regression you're doing. And so when I click to the right here, notice I see cubic regression, exponential regression, linear regression, natural log regression, power regression. Those are the ones that we will be kind of choosing from. So this LIN is linear regression. You're going to choose that as the calculation type because it asks you to, even though the scatter plot's not necessarily aligned, we select that as our linear regression, and now notice it opens up the fields for both the x and the y. Okay, so we entered the x coordinates in column 1, so C1 is what you would enter here. And then scroll down to the next line, the y's are in C2. Now remember, if you're using the keyboard here to select it, it'll automatically alpha lock, so make sure you have C1 and C2 there. And here's where, again, the TID9 can be more useful. Is the very next line down, it says store regression equation 2. And so what you can do is you can actually store that equation to your Y editor. And so if you select one of these, I'm going to just put it in as Y1 here and hit enter, and then hit enter again. It gives you the information for that. So notice that we get the same answer here, right? 2.4 is my A value, so 2.4x plus 551.6. It's the exact same answer that we got on Excel. The only difference would be is if they wanted you to evaluate, let's say, when y is 10 on this, it would be easier to do that on the calculator, because if I go to the home screen, if I input y of x, that's going to pull up, y1 of x. So y1 of x is where I stored that equation. If I enter that, it pulls up the actual equation for you, which means if I wanted to evaluate y1 at 10, I can evaluate that function using function notation, and it gives me my answer 576 or 575.6. If that again was what they were asking me to do. So when you have to, if you have to extrapolate or interpolate the data, TID9 might save you a little bit of time. I still strongly recommend the Excel spreadsheet to do it, but you can use either one. All right, so let's look at the next type of equation, which is quadratic regression. And quadratic regression is going to be the form ax squared plus bx plus c, quadratic function or quadratic equation. But the steps are identical. Okay? So if I'm using an Excel spreadsheet for this, I'm going to enter my data. So I'm going to go ahead and just use the same data set that I have right here. So 1, 2, 3 stays the same, then 6, 9, 14. So I'm going to change that data, and then I'm going to change the corresponding numbers. All right, so as I've changed the numbers, what winds up happening here is my graph has changed, right? But I'm no longer, I don't want this linear equation anymore, right? This is no longer a linear form. It specifically asks me for a quadratic, or it means it has a shape of a parabola. So if I click on this line here, okay, so I clicked on this line of best fit that was on here, and notice it brings up my options to change this from linear to polynomial. And then the order is the degree. So quadratic equation has a degree of 2. Notice it fits that the information, the data set perfectly on this. And so you have your equation here for your line of best fit. Now, if it asks you to round to a specific decimal, this one asks you to round to 1. So you have your equation right here. If you want it to automatically round to 1 for you, and if you click on this and then choose the labeling conventions, you can change that to a 1 if you want. And notice when I do that, these are now changed as well. So there is the formula, or the equation for this line of best fit, which is negative 4.9 x squared plus 31.5 x, and then plus 70.0. Okay, so include that 0.0. It asks you to round it to 1 full decimal, and so that would be included in it. And now, it also asks you on this one to estimate your profit if you sold 5 items. So 5 items would be what? Interpolating or extrapolating? It falls within that range of value, so it's interpolating it. So what I'm going to do on this is I can either write this equation on a calculator, replace my x's with a 5 and calculate, or, again, because you're working on the computer here, I'm just going to highlight my equation, copy it, so Control-C. I'm going to paste it here in a cell. I need to put an equals in front, so it calculates for me, turns it into a formula. And the Excel has no implied multiplication. So even if I did this, 5 squared, and put that inside Excel, it doesn't know that you're multiplying there unless you specifically use the asterisk as a multiplier. And so times 5 squared, and then right here, times 5. Get rid of your x's, and once you do that and hit enter, it'll give you the numerical value. And for this one, it's a 105. It asks you to round to 2 decimal places, so again, to be consistent, 105.00. is what you would get. Okay. All right. So I want you to see if you can do the same thing here, okay, and find the equation of the line of best fit and evaluate, in this case, for the year 2024. Oops. And let me add one thing. I changed it already on the actual homework, but right in this spot right here, there's going to be an instruction that says, make a scatter plot of this data, and it's going to be using years since 2010 as your inputs. And what that means here is you're not going to use 2010 as your X input. What are you going to actually use for that? 2010 you're going to use 0. 2011 you'll use 1, 2, 3, 4, 5, 6, 7, 8. Do you guys understand why that is? Okay, so it will specify if it asks you, your input is the years since some other number. If you use 2010 as, or the full years for your inputs, you will get the right answer for part B, but you're going to get the wrong equation for part A. So just make sure that you're using the correct values of your time inputs as years since 2010. All right, so here when I enter this, I can go ahead and just, I'm going to move some things around a little bit, but I'm just going to replace what I have. I have 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I'm going to move this down even a little bit more. And then as I enter my corresponding pieces, -7, -1, 3, 7, 15, 17, 31, 49, and 59. Okay, now notice when I click on my my graph here, I'm not actually seeing, and the graph's not actually using all of the data points, right? So I need to change this. So when I highlight it, I'm going to change. Now notice, now it does contain all of them. It gives me a regression line for this, and my equation of best fit is right here. Now the problem asked me to round to 2 decimal places, so I need to go back into this, and if I double click on that formula box right here where it turns to the crosshairs, I can go into my number labeling options. What did it say, 2 or 3? It says to 2 decimal, so if I change that to a 2, okay, I've now got my equation here for the line or the equation of best fit. And that is this 1 point, point. Okay. And so I have this equation here of 0.88 x squared plus 0.97 x, and then minus 4.58. Okay. Is that what you guys got as well? Okay. And so then when we want to evaluate this, we can highlight this whole equation here, and then find a cell, enter that, so equals that, and again I need to replace my x's with this number here for the year 2024, and what's that number that I'm going to use to evaluate. So here I'm going to take f of 2024 is 14 years since 2010. So I evaluate that for 14, and so each of these x's I'm going to put times 14 squared plus 0.97 times 14. Get rid of my variables in there, and when I hit enter, I get my answer 181.48 as my solution. Okay. All right. Questions on that? So there's two remaining types of regression equations that you're going to be using here. The next is called a power regression. A power regression has the form y equals a times x to some power. Okay, but really, it's no different whether it's on your T99 or Excel. You're going to enter your data just like you did from before. So here, if we look through this example, I'm going to go in, I'm going to change my data here to 7, 8, 9, 10, 11, and 12. Okay, I don't need any of this remaining data. I'm going to change the corresponding outputs, 34, 37, 43, 40, 43, and 41. So there's all my data right here. Notice that this one specifically tells me use the power regression. So I'm not going to use the quadratic regression like I have set in my graph right now. If I go back into this and I click on my line, I double click on that, the dashed line here, the dotted line, and I'm going to change it from polynomial to, I was told it's a power function. Okay, and so that's the power function that I choose. And when I do that, I see my answer right here. Now it's specified this time 3 decimal places. I only have 2 right here. So if I go to this and double click on this box, I can change the number of decimal places to 3. And so there is my answer. And I can enter that. I get y is equal to 17.428 times x to the power of, and I can see on that it is 0.366. And so that is my formula. Okay? If you're evaluating it like you're going to do on the next example of this, you would plug that into a cell and type in the number you want to evaluate. So I want you to try the second example here of evaluating power regression. All right, so I'm going to go ahead and enter this as you guys are finishing your All right, so I've entered my data. When I click here on this, I just see that I don't have all of it included in my graph, so I'm going to highlight all of that. And now I do. This gives me the formula that I'm looking for. It's already rounded to 3 decimals, so there's my equation, 8.531. Notice here in the instructions, make sure to use d as your variable. You can see it in the function notation. You don't want to write x here. So it's 8.531 times d to the power of. And then here in this form, I see 0.649. And so that is my equation for the best fit. And now I want to evaluate it when x or d is 43. So if I go into this right here and I highlight my equation part, go to an empty cell, enter that, I need to replace my x, again, times the base of that is 43. That's what I'm evaluating. To the power of this decimal number here was my power. And so when I hit enter, I get my answer to be 97. And just go ahead and round this to 3 decimals as well, since it asked you at the earlier part. So 976. And that would be my value. All right. So the final example is an exponential regression. And this is one where, once again, so the TI-89 may actually be easier to use for this. It all depends on what you, like how you think about these. But if I have time here, we're running short on time. But if I have time, I'll do both TI-89 and Excel. But here, if you're using Excel, this is now asks you for an exponential regression. So here, when I enter my inputs, oops. Right. So once again, I can remove these. I don't necessarily have to. But when I go into my graph here, I am going to just go ahead and select just the cells that I want. Okay, now, remember, this is not a power function anymore, so this isn't the equation I'm looking for. This is now an exponential regression, and that has the form y equals a times b to the power of x. So that's what the exponential regression is going to be. The base, the unknown is not your base, the unknown is your power here. And so when I enter this data and I want to change my graph style, this equation style, if I double click on this dashed line, pull up the options here, and I'm going to choose exponential. Okay. Now here's where this differs from your TI-89s. The Excel uses a base E. Okay. The calculator or the problem's not asking you for a base E, okay, because you want your power to just be x. Okay. And so what you need to be able to do here, if you're entering it this way, is instead of writing your answer, so let's say that Excel tells us we have 726.909 e to the power of 0.142 x, right? But we don't want base e to the power of 1.42. Oops, you guys can't see what I'm writing, do you? All right, so we don't want this to be 726.909 e to the power of 0.142 to the x. Well, we want that to be just one single base to the power of x. So what you'd have to do if you're using this Excel is your A value here, this multiplier in front, is the 726.909. So we have that number. But our B value is this whole thing. We have to evaluate what is e to the power of 0.142. So we'll do that on a calculator. Here, if I take e to the power of 0.142, that is my base B. Again, rounded to 3 decimals, so I get 1.153. Okay, so try the second example doing that on your own, writing the full equation, please. All right, so if I enter my data sets, 1, 2, 3, 4, 5, 6, those are my inputs already there. Change what I have here, 691, 796, 1002, 1165, 1395, and 1706. All right, so I don't have to change anything. Everything, or here, everything should be done. It models what I'm looking for, but this one does ask me to round to 4 decimal places. Okay, so I do need to make sure I add a decimal place. So I highlight, I'll go to the full size, highlight my formula, double click where it turns into this this little arrow, the crosshairs here. And then I'm going to open up numbers, change this to 4 decimal places. That gives me the answer that I'm needing to enter. And so I have 568.5845 all times. Now, again, here it gave me my base as I write this, e to the power of 0.1815, rounded to 4 decimals. So I'm going to go into my calculator, evaluate what that is. So 0.1815, close that off and find it. It's 1.1990. So that's going to be this base, 1.1990 to the power of x. All right, so didn't give you any